All right, hi everyone. Welcome back to our STEM Expo. Today we have Dr. Jessie Christiansen. Dr. Jessie, would you mind introducing yourself for our viewers?
Hi everyone, I'm Jessie. I work at IPAC on the Caltech campus. You probably haven't heard of it. It stands for the Infrared Processing and Analysis Center, and it's where NASA does a lot of their public data archiving and processing and releasing of data.
I see. It's very cool. I noticed some interesting history to IPAC and its relationship with JPL. Can you tell us more about that history?
Sure. So JPL, which is just up the road from IPAC, is where a lot of the really interesting rocket propulsion stuff was happening in the 50s and 60s. It was very secret. There were fences and people with guns. It was all very under lock and key. And then when NASA data started to come out and they realized they wanted NASA data to be public, they were like, well, it doesn't actually need to be behind all of these fences and people with guns. So they came down to Caltech campus and they started this center, IPAC, this Science Data and Analysis Center. So we serve all of NASA's public data from many of its missions.
That's really awesome. And so can you tell us more about your role within IPAC? Do you do research? Do you manage data? Do you do a mix of both? Can you tell us more?
Yeah, so I actually really love my job here. So I'm a research scientist at IPAC, which means I spend 50% of my time supporting the NASA project that I work on, that I'll talk about, and 50% of my time doing my research. There's another track here at IPAC for scientists called the Staff Scientist track, which is an 80-20 split, so 80% of time supporting a science project and 20% doing your own research. And people like those different tracks for different reasons, but I really love the research. So the project that I support is the NASA Exoplanet Archive, and this is how NASA keeps track of all of the exoplanets we've found, which are planets outside our solar system. And so far we've found over 5,000.
Wow.
So what the archive does is keep track of how many we found, anything we know about them, their temperature, their size, where they are, what kind of star they orbit, for everybody to use in their science. My research part is I like finding planets, so I use NASA's missions like Kepler and K2 and TESS to actually search for planets around other stars. And luckily enough, I get to find some, and then they go into the archive.
Wow, that's really cool. What's like the coolest thing you've seen? I can imagine like finding exoplanets must be like an amazing thing. Do you have any like particular cool stories or cool facts you've seen here?
Well, so one of my favorite systems that I got to be very lucky to lead the discovery of is called K2-138. I'm going to stop now and apologize. Exoplanets have terrible names. I'm very sorry. I don't actually get to name them. There's a rule we have to follow, and it's a garbage rule. Anyway, so the system is called K2-138. The reason I love it so much is it was found by citizen scientists.
Oh.
So people at home on their computers looking through NASA data. So my colleagues and I set up this citizen science project on a website called Zooniverse, which hosts many citizen science projects, where we served Kepler data and we were like, help us find the planets in these data. Because we write software to search the data and look for planets. But when we're writing software, we're making assumptions about what it's looking for and what the data look like. So the computer does a really good job of finding that exact thing. But stars do all sorts of interesting things, and planets do all sorts of interesting things. So what's very difficult to do is tell the computer, look for something surprising, look for something weird, look for something that stands out. But you can tell a human brain to do that pretty easily. Like we show you what a signal looks like and then go to the data and say, hey, what do you see? And people see everything. They're like, what's this? What's this? What's this? It's like the face in Mars, but in Kepler data.
Wow.
So they found this system, and I was lucky enough to, be part of this project and help turn that system into a confirmed system. Now has 6 planets in it, and citizen scientists found, I think, all 6. So that was really, really marvelous to be part of, and so exciting to get to include the citizen scientists on my paper as co-authors.
Wow, that's actually crazy. So I imagine like this is something that people of a lot of ages can do. It's not just people with PhDs and stuff. So.
Yeah. So the whole point is, in 2 minutes on the website, we show you what a planet looks like and what it doesn't look like, and then you just go. And then, honestly, it's as much time as you can devote to it. So we have TESS data right now. This is NASA's Transiting Exoplanet Survey Satellite mission called TESS. And data are coming down from TESS every 2 weeks. So if you go to planethunters.org, which is our TESS citizen science project, you can actually start looking for planets right now.
All right, so maybe our competitors can do this, but after the national tournament day, maybe not quite beforehand. But yeah, that sounds like a fun opportunity. So I wanted to ask, because I know a lot of people might have the image of, getting into research as like this one track of like going undergraduate, graduate school into PhD. having to do academic research at a university, or that's it. Now, it sounds like your work is a little bit different, and your pathway is also a little bit different. Can you tell us about that pathway?
Yeah, so, growing up in a small town in Australia, I had no idea about academia and universities and that kind of thing. So when I got to university, I had no idea what kind of job you could do in astronomy. And that was when I started to discover that there are all these different careers you can do just, starting from a degree in astronomy. So working, for instance, at a government institution, doing program support and doing your own research is one of those things. You can also work at observatories, for instance, being telescope operators and doing that kind of thing. Or you can work on what we call soft money, which is where you apply for grants and then you pay yourself to do the science that you've promised to do. That one's hard, but some people can make it work if they write convincing proposals. And then the last one is becoming a professor at a university and doing your own research. So there are lots of different things you can do to have a career in astronomy. And that's just research related. There's all these adjacent things like science communication and instrument building and science policy. There's lots of really interesting astronomy adjacent jobs as well, not just being a professor.
It's cool that there's so many fields and ways of getting into research and science, no matter who you are. I guess our final question is, it's almost competition day, and middle schoolers and high schoolers across the nation are probably going to be listening to this. Do you have any final words of advice for them?
Have fun. This is so exciting, and I'm so proud of all you guys for making it to this. What an opportunity. So, meet people and have fun and really just enjoy the day.
All right. That was Dr. Jessie Christiansen. Thank you so much for taking the time to speak with us today, and good luck to everyone. Bye.
Bye.